We are now on the third chapter of Mechanics 102, and it is all about kinematics of rigid bodies. In this chapter, we will be dealing with objects in motion. We will be considering or investigating the relationship between time, position, velocity, and acceleration of moving objects. And there are various types of rigid body in motion. We have translation, rotation about a fixed axis, general plane motion, motion about a fixed point, and the general motion. And to begin with, let us start with the first type of rigid body in motion, which is the translation. So translation, a motion is said to be a translation if any straight line inside the body keeps the same direction during the motion. It can also be observed that in a translation, all the particles forming the body move along parallel paths. So let us consider a rigid body here, and inside the rigid body are particle A and B. So the line joining the origin to the particle A is what we call the position vector A, and then the line that is joining the particle B from the origin is what we call the position vector B. And then the line joining these two particles is the position vector of B relative to A. So the position vector of B relative to A must maintain a constant direction. And if it is in constant direction, its magnitude must also be constant. So since A and B is positioned or can be found in a single rigid body, if we take the derivative of the position vector of B relative to A is equal to 0, we can assume that the velocity of B is now equal to the velocity of A, and then if we take again the derivative of this equation, we can say that the acceleration of B is equal to the acceleration of A. So this formula is only applicable if the particle belongs, or if these two particles belong to a single rigid body. So here in the translation, if the paths are straight, or if the paths are moving in a straight line, the motion is said to be in a rectilinear translation. But if the paths are in curved lines, the motion is in a curvilinear translation. So kindly take note that when a rigid body is in translation, all the points of the body have the same velocity and same acceleration at any given instant. So as the formula is showing here, when a rigid body is in translation, all the points of the body have the same velocity and the same acceleration at a given instant. So for curvilinear translation, the velocity and acceleration change in direction as well as in magnitude. And for rectilinear translation, all the particles of the body move along a parallel straight lines, and their velocity and acceleration keep the same direction during the entire motion. So summary lang ng translation, when a rigid body is in translation, again, all the points of the body have the same velocity and same acceleration at a given instant. So yun lang yung dinidescribe ng ating translation. Next, we have the second type of rigid body motion, which is the rotation about a fixed axis. So in this motion, the particles forming the rigid body move in parallel planes along circles centered on the same fixed axis. If this axis, called the axis of rotation, intersects the rigid body, the particles located on the axis have zero velocity and zero acceleration. So let us take a look on this diagram. So the rotation about a fixed axis, sinasabi niya lang na if we have an axis of rotation, which is this line, all the particles that is a position or that can be found in the axis of rotation, the velocity and the acceleration is equal to 0. So ito yung ating axis of rotation. So the particles that is positioned or that can be seen aligned on the axis of rotation, their velocity and their acceleration is equal to 0. So for any particle that is not positioned on the axis of rotation, like for example here our particle P, a line connecting from the origin to the position of our particle is position vector r, and then it creates an angle between the axis of rotation and then with our position vector r that we can denote as our phi. And then the angle that is formed in the plane is what we call the angular coordinate or the time derivative. So our theta here is the angular coordinate. Our r here is the position vector. So if we want to determine the velocity of this particle, we will take the derivative or the first derivative of the distance with respect to time, or we can express it as the position vector r multiplied by the angular coordinate multiplied by sine phi. And on the axis of rotation, the angular velocity is expressed as the first derivative of our angular coordinate multiplied by a certain constant k. Or we can also determine the velocity of the particle by having the first derivative of our position vector with respect to time, or can be expressed as the vector product of our angular velocity and position vector. So the vector omega is equal to the magnitude of the angular velocity multiplied by a certain constant k, or as I have said earlier, the first derivative of the angular coordinate multiplied by a constant k. So this angular velocity is equal in the magnitude to the rate of change of the angular coordinate. So, sulat lang natin dito. Again, theta is what we call the angular coordinate. Our omega is the angular velocity. And later on, we will be encountering alpha, which is our angular acceleration. So if we take the derivative of the angular velocity, makukuha natin yung ating acceleration. And the acceleration of the particle P can be expressed as the vector product of the angular acceleration and a position vector plus the vector product of the angular velocity and the vector product between the angular velocity and then the position vector. Or in other words, our angular acceleration is just the derivative of the angular velocity with respect to time, or can be also expressed as the angular acceleration is equal to the magnitude of the angular acceleration multiplied by the constant k, or the first derivative of the angular velocity, or in other words, the second derivative of the angular coordinate. So next we have the rotation of a representative slope. So we will consider the motion of a representative slope located in a plane perpendicular to the axis of rotation of the body. And since the angular velocity is perpendicular to the slope, the velocity of a point P of the slope was expressed as v, or the vector product of the angular velocity with the position vector r. So let us take a look on this diagram. So we will consider the x and y plane as the reference plane only. So imagine nyo that the z-axis is pointing towards you or pointing towards the paper. So we have only the x and y plane. So we will be considering a portion of the slab that is perpendicular to the axis of rotation, which is yung axis of rotation natin is the z-axis. Kaya hindi nyo makikita yung z-axis dito because we are looking at the perpendicular axis of rotation, which is the x and y plane only. So we have here a particle P, and again the line that is connecting the origin to the particle is our position vector r, and it has a certain velocity which is expressed by this vector product. So it also shows here the acceleration of the particle, which is given by its component, the tangential component and then the normal component. So the tangential component is expressed as the vector product of the angular acceleration multiplied by the position vector. And then the normal component of the acceleration is given by this formula, which is the negative product of the angular velocity squared multiplied by the position vector r. So recalling that our angular velocity is equal to the magnitude multiplied by a certain constant k, we note that the positive value corresponds to a counterclockwise direction or rotation of the slab, and the negative value corresponds to a clockwise direction. So kindly take note of these orientations, that if we have a positive value of the angular velocity, meaning it corresponds to a counterclockwise rotation of the slab, and if it is in negative value, it signifies or shows a rotation that is in clockwise motion. So in other words, the acceleration of point P is expressed as the vector product of the angular acceleration and then the position vector r minus the square of the position or the angular velocity multiplied by the position vector r, in which the tangential component is equal to the vector product of the angular acceleration and the position vector r, or can be expressed as the product of position vector r and then the angular acceleration, and then the normal component of the acceleration of point P is equal to the negative value of the angular velocity squared multiplied by the position vector r, or can be expressed as the product of the position vector r multiplied by the square of the position or angular velocity. So kindly take note of these formulas and these orientation. Next, we have the equation defining the rotation of a rigid body about a fixed axis. So the motion of a rigid body rotating about a fixed axis is said to be known when its angular coordinate theta can be expressed as a known function of time. The conditions of motion will be specified by the type of angular acceleration that the body possesses, in which our angular velocity is expressed as the first derivative of the angular coordinate with respect to time, and the angular acceleration is equal to the first derivative of the angular velocity with respect to time, or the second derivative of the angular coordinate with respect to time, or can be written as the product of the angular velocity and then the derivative of the angular velocity with respect to the angular coordinate. So these formulas were discussed on the previous slides. So we have two particular cases of rotation that are frequently encountered. First is the uniform rotation. So this case is characterized by the fact that the angular acceleration is equal to 0 and the angular coordinate is given by the formula in which the angular coordinate is equal to the initial angular coordinate plus the angular velocity multiplied by the time. And then the second one is the uniformly accelerated rotation. So the angular acceleration is constant. The similarity between the formulas derived here and those obtained for the rectilinear uniformly accelerated motion of a particle is apparent, in which our angular velocity is equal to the initial angular velocity plus the angular acceleration multiplied by the time. And then the angular coordinate at any position is equal to the initial angular coordinate plus the initial angular velocity multiplied by the time plus 1/2 of the angular acceleration multiplied by the time squared, and then the square of the angular velocity at any point is equal to the square of the initial angular velocity plus twice the angular acceleration multiplied by the difference of the angular coordinate at any position minus the initial angular coordinate. So these formulas are familiar sa inyo in the motion of a particle in a straight line, tama? So for the uniform rotation, the acceleration is 0. So the angular acceleration is 0. So kung maalala nyo, in chapter 1, we have our x is equal to the initial position plus the velocity multiplied by time. So parang magkamukha lang sila, which is sinisimplify lang ng ating third chapter yung motion of a particle in a three-dimensional way. So dito naman sa uniformly accelerated rotation, the angular acceleration is constant. So it looks familiar, in which our v is equal to the initial velocity plus acceleration time, and then our x is equal to x initial position x plus velocity multiplied by the time plus 1/2 a t squared, and then v squared is equal to the initial velocity squared plus 2 acceleration, and then x minus x0. So yan, they look familiar. So for you to be able na matandaan siya agad, you only have to remember these formulas on the first chapter. So which is equal, yung x natin, yung position x natin is equal to the angular coordinate, and then yung velocity natin is equal to omega, or the angular velocity, and then yung acceleration natin is equal to the angular acceleration. So these are some points for you para mas maalala pa yung formula. For our first example, the brake drum is attached to a larger flywheel that is shown. The motion of the brake drum is defined by the relation angular coordinate is equal to 36t minus 1.6t squared, where theta is expressed in radians and t in seconds. Determine the angular velocity at t is equal to 2 seconds and the number of revolutions executed by the brake drum before coming to rest. So we have here the formula of the angular coordinate is equal to 36t minus 1.6t squared. So we will determine the angular velocity. So angular velocity is our omega at t is equal to 2 seconds. So to be able to have an equation for our angular velocity, we will take the first derivative of the angular coordinate with respect to time. So it is equal to 36 minus 1.6 of t. So it is equal to 36 minus 3.2 t. So this is now our formula for the angular velocity. So at t is equal to 2 seconds, our angular velocity is equal to 36 minus 3.2 of 2. So the angular velocity at 2 seconds is equal to, so it is equal to 29.6 rad per second. So our angular coordinate is expressed in radians and time in seconds. So our angular velocity is in rad per second. So this is our answer for letter A. For letter B, the number of revolutions executed by the brake drum before coming to rest. So before coming to rest, so the velocity is equal to 0 na. So if an object is coming to rest, the velocity will be equal to 0, or our angular velocity is equal to 0. So equate lang natin yung equation natin into 0. So our angular velocity is equal to 36 minus 3.2 t. So equate natin siya in 0. So the object will come to rest at time is equal to, so this is minus the, is equal to 11.25 seconds. So the brake drum will stop at 11.25 seconds. So the problem is asking for the number of revolutions executed. So number of revolution executed meaning the angular coordinate theta. So angular coordinate theta, our equation is 3060 minus 1.6p squared. So i-equate lang natin or i-substitute lang natin yung time natin into 11.25 seconds. So it is equal to 36 of 11.25 minus 1.6 of 11.25 squared. So the angular coordinate is equal to, so it is equal to 202.5 rad. But the problem is requiring for the number of revolutions. So in one revolution, we have 2 pi rad. Therefore, our angular coordinate is equal to 32.2 revolutions. So the answer for letter B. For problem number 2, load B is connected to a double pulley by one of the two inextensible cables shown. The motion of the pulley is controlled by cable C, which has a constant acceleration of 9 inches per square seconds and an initial velocity of 12 inches per second, both directed to the right. Determine the number of revolutions executed by the pulley in 2 seconds, the velocity and change in position of the load B after 2 seconds, and the acceleration of point D on the ring of the inner pulley at t is equal to 0. So, for letter A, we will determine the number of revolutions executed by the pulley in 2 seconds. So, for the motion of the pulley, the velocity of point D and point C is equal. So, yung velocity at this instant is equal to the velocity at point C. And then, the tangential component of the acceleration of D is equal to C also. So, let us denote that the initial velocity at point D is equal to the initial velocity of point C, which is equal to 12 inches per second, as is stated in the problem, which is going to the right. And then the acceleration, or the tangential component of the acceleration, is equal to the acceleration of point C, which is equal to 9 inches per square seconds. And it's going to the right. So we know that velocity is equal to the angular velocity multiplied by position vector r. And our acceleration, or our tangential component of acceleration, is equal to the angular acceleration multiplied by the position vector r. So for this formula, our velocity is equal to 12 inches per second. Our angular acceleration multiplied by the r, position vector r, which is 3 inches. Therefore, the angular velocity is equal to 4 rad per second. And then yung ating acceleration, our acceleration is 9 inches per second squared, so 9 is equal to our angular acceleration multiplied by 3. Therefore, our angular acceleration is equal to 3 rad per second squared. So as you can see, papunta dito yung direction ng velocity natin. So we can assume that the angular velocity is in clockwise motion kasi papunta nga doon. So ganyan yung magiging motion niya. And then also the acceleration is in clockwise direction. So you can say that the angular acceleration is constant. So kung constant yung angular acceleration niya, we have a formula here. So our formula for the angular velocity is equal to the initial angular velocity plus the angular acceleration multiplied by the time. So the initial angular acceleration is equal to 4 rad per second plus 3, and then at time is 2 seconds, so 2 seconds. Therefore, the angular velocity is equal to 10 rad per second in clockwise motion. And for the angular coordinate, we have the equation angular coordinate is equal to the initial angular coordinate plus the initial angular velocity multiplied by time plus 1/2 angular acceleration of t squared. So substitute lang natin. The angular coordinate, or the initial angular coordinate, is equal to 0 plus the initial angular velocity 4 rad per second multiplied by time. Yung time na hinihingi is at 2 seconds, so 2 plus 1/2, yung angular acceleration natin is 3 at 2 squared. Therefore, the angular coordinate is equal to it is equal to 14 rad. And the problem is asking for the number of revolutions. So for number of revolutions, i-multiply lang natin siya into 1 revolution to 5 rad. Therefore, the angular coordinate is equal to, so it is equal to 2.23 revolutions. So this is our answer for letter A. And then for letter B, the velocity and change in position of the load B after 2 seconds. So yung position daw, change in position and velocity of this point B. So for letter B, we will solve the velocity and change in position of load B after 2 seconds. So the change in position and change in velocity. For letter B, we will determine the velocity and change in position of the load after 2 seconds. So we will determine the change in position of this load and its velocity at 2 seconds. So velocity is equal to the angular velocity multiplied by the position vector r, in which yung angular velocity natin, we have solved that at 2 seconds it is equal to 10 rad per second. So balikan nyo yung letter A natin. So velocity is equal to 10 multiplied by, so we are now on this circle. Kung i-consider natin r is 5 inches. So 5 inches, so it is equal to 50 inches per second. And then the change of position of load B. So change in position of our load B, which is equal to the position or the angular coordinate multiplied by our vector r. So we have solved kanina that our angular coordinate at 2 seconds is equal to 14 rad. So 14 rad multiplied by 5 inches. So it is equal to 14 times 5, so it is equal to 70 inches. So in upward motion, so this is in upward motion, and then also the velocity is in upward motion. So this is our answers for letter B. So kung mapapansin nyo, in angular coordinate, ang ating unit is in rad. And yung angular velocity natin, it is expressed in rad per second. But if we proceed to the rectilinear motion, yung velocity natin will change into inches per second. And then yung ating position is expressed in inches or meters or whatsoever. So kindly take note that if we are considering kinematics of rigid bodies, the units for angular velocities, angular acceleration, and angular coordinate are expressed in rad, revolution, or in degrees. So these are the units na i-consider natin if we are involving kinematics of rigid bodies. So for letter C, the acceleration of point D on the rim of the inner pulley at time is equal to 0. So for letter C, the acceleration of point D on the rim of the inner pulley at T is equal to 0. So the tangential acceleration at point D is equal to acceleration at point C, which is equal to 9 inches per second squared. So at time is equal to 0, our angular velocity is equal to 4 rad per second. Therefore, the normal acceleration or the normal component of the acceleration, which is equal to the product of the position vector multiplied by the square of the angular velocity, in which yung i-consider natin r is to 3 inches. So kasi dito lang tayo maglalaro at this circle. So 3 inches. And then our angular velocity is equal to 4 rad per second. Therefore, the normal component of the acceleration is equal to, so it is equal to 48 inches per second squared downward. Therefore, the acceleration at point D is equal to the tangential component squared plus the normal component squared. So it is equal to 9 squared plus 48 squared. So it is equal to 48.84 inches per second squared. So, kung ito drawing natin, ito yung tangential component ng acceleration, which is 9 inches per second squared, and then the normal component, which is 48 inches per second squared. So therefore, yung acceleration natin is directed on this part or on this position. So kukunin natin yung angle with respect to the horizontal reference. So kung kukunin natin, it is equal to tangent, theta is equal to opposite, which is 48, all over adjacent, which is 9. Therefore, theta is equal to 79.38 degrees. Therefore, the acceleration of point B on the rim of the inner pulley at t is equal to second is equal to 48.84 inches per second squared, directed 79.38 degrees with the horizontal. So, ganito nyo dapat i-express yung inyong final answer. For letter B, we will determine the number of revolutions that the motor executes in coasting to rest. So we have here the word rest, meaning the velocity would now be equal to 0, or the angular velocity would now be equal to 0. Therefore, our formula, so 0 is equal to our initial angular velocity when the wheel is turned on is equal to 120 pi, as we have solved earlier. So 120 pi plus, this is alpha. So angular acceleration multiplied by the time, which is yung time natin is in 70 seconds. So since the velocity will soon come to rest, we will change the sign into negative, because the velocity will soon come to rest. Therefore, our angular velocity, or the angular acceleration rather, will now be equal to, so it is equal to 12 over 7 pi rad per second squared. And we have our formula for angular coordinate. So our initial angular coordinate is still 0. Plus 120 pi 70 plus 1/2 of 12 over 7 pi multiplied by 70 squared. Therefore, the angular coordinate is equal to So for letter B, we will determine the number of revolutions of that motor when coasted to rest. So we have the word rest here, therefore the velocity would now be equal to 0. So we have the formula. So this must be alpha. So we have for letter B, we will determine the number of revolutions that the motor executes when coasted to rest. So we have here the word rest, meaning the velocity would now be equal to 0. And we have our formula here. sorry, this is alpha. So 0 is equal to our initial velocity when the grinding wheel is turned on is equal to 120 pi as we have earlier, plus our acceleration multiplied by the time, which is 70 seconds na i-consider natin. Therefore, the acceleration or the angular acceleration is equal to negative 12 over 7 pi rad per second squared. And then we have our formula for angular coordinate, which is equal to the initial angular coordinate plus the angular coordinate, initial angular coordinate is 0 plus 120 pi, and then our time is 70 plus 1/2. The acceleration is negative 12 over 7 pi. Time is 70 squared. Therefore, the angular coordinate is equal to so it is equal to 4,200 pi rad, and it must be expressed in revolutions. So this 2 pi rad in every revolution. Therefore, it is equal to 2,100 revolutions. 2,100 revolutions. So this is our final answer for letter B. For the next example, the belt sander shown is initially at rest. If the driving drum B has a constant angular acceleration of 120 rad per second in counterclockwise direction, determine the magnitude of the acceleration of the belt at point C when the time is equal to 5 seconds or 0.5 seconds and 2 seconds. So this is the belt sander, and it has a constant angular acceleration of 120 rad per second squared in counterclockwise direction. So, pag ganun yung direction ng ating belt. So, we will determine the magnitude of the acceleration of the belt at point C. So we have the normal component of acceleration is equal to the position vector r multiplied by the angular velocity squared, and then the tangential component is equal to the position vector r multiplied by the angular acceleration. So therefore, our tangential component for acceleration is equal to, so yung r na consider natin is 0.025 meters or 25 millimeters. So this one, so 0.025 meters, and then our alpha is 120 rad per second squared. Oh, this must be 120 rad per second squared. So therefore, is equal to 3 meter per second squared. 3 meter per second squared. And then, so ito yung point C natin. So the motion is in clockwise direction. Therefore, the tangential component ng ating acceleration is position downward, and then yung normal component natin is position to the right. So this is AN, this is AT. For this, we will determine the angular velocity omega, and our angular velocity is equal to the angular acceleration multiplied by the time, right? So it is equal to 120 rad per second squared multiplied by the time, which is 0.5 seconds. So it is equal to 60 rad per second. Therefore, our normal component of acceleration is equal to 0.025 meters, and then the velocity, angular velocity, is 60 rad per second squared. So it is equal to 90 meter per second squared. Therefore, our acceleration is equal to square root of the tangential component and the normal component. So it is equal to 3 squared plus 90 squared. So the acceleration is equal to 90.05 meter per second squared. Therefore, this is the magnitude of the acceleration at 0.5 seconds. So at t is equal to 2 seconds, so for the tangential component, so same din kanina, so it is equal to 3 meter per second squared, so parehas lang nung kanina. And then our an, we need to find the value of the normal component, which is equal to 120, and then the time is 2 seconds, therefore it is equal to 240 rad per seconds. So our an is now equal to 0.025 meters. The angular velocity is 240 rad per second, so it is equal to 6. So it is equal to 6 so it is equal to 1440 meter per second squared. So our acceleration therefore is equal to 3 squared plus 1440 squared. Therefore, the acceleration is equal to 1440.003 meter per second squared, because the tangential component of the acceleration is very small compared to the normal component of the acceleration. So this is the final answer. Take note that the relative velocities of b with respect to a and a with respect to b have the same magnitude but opposite sense. So same magnitude lang yan, but opposite sense or different direction. So next is the general plane motion. So any plane motion which is neither a rotation nor a translation is referred to as a general plane motion. However, a general plane motion can always be considered as the sum of a translation and a rotation. So take note of this. General plane motion is considered as the sum of the translation and the rotation. So we have three figures here that shows the sum of the translation and rotation. So we have here translation, rotation, and then translation, rotation. So let us focus first on the first diagram. So imagine that we have a wheel that is rolling on a straight track. So this is the initial position of the wheel, and sometimes it rotates or it moves from point 1 to point 2. So this position is composed of two motions, the translation and the rotation. So translation, as discussed on the first part, a motion is said to be a translation if any straight line inside the body keeps the same direction during the motion. So, as you can see, straight line yung involved dito. So, this is the position from point 1 to point 2. Ito yung straight line motion na tinutukoy ng ating translation. And, yung rotation na nangyari from point 1 to point 2. So, let us consider particle B moving at a certain point 2. So, it creates an angle as it rotates about A. So, another diagram here. So, it shows a translation with A and a rotation about A. So, we have a rod here, a rod AB. So, ito yung original position ng ating rod AB. Positioned at 1. So, yung movement ng ating rod A is vertically downward and then horizontally to the right. So, yun yung motion niya. And yung motion na to is caused by a translation and a rotation. So, for translation, which is the movement of point 1 to point 2, and then yung rotation ng ating point B or B1 to B2, rotation about A. So, at this second diagram, we are considering the translation in a horizontal motion ng ating point A. So, same scenario then, if we will consider point B, we will consider the vertical movement of point B. So point B naman tayo mag-focus. So, yung motion ng point B is downward direction vertically. So, same then. Yung A natin is going to the right. So, yung translation na magaganap sa B is downward motion vertically. And of course, imaginary, let us take the position of A1 papuntang A2. So, ito yung magiging translation ng ating particle B or point B. And then also, it creates a rotation about B. So, mag-create siya ng angle now from the original position to the imaginary position ng ating rod AB. So, I said that it's imaginary kasi hindi naman talaga mangyayari itong layout na to since yung ating A and B is in a roller. So, yung motion lang niya is pa ganun for A, either left or right, and then yung B natin is either downward or upward. So, never mangyayari in the instant na yung A natin is gagalaw vertically and at the same time, at this point, yung B natin is gagalaw horizontally. So, we also have the absolute and relative velocity in plane motion. So, the absolute velocity of particle B of the slab is obtained from the relative velocity formula, which is the velocity of B is equal to the velocity of A plus the relative velocity of P with respect to A, where the right hand member, so ito yung right hand member niya, represents a vector sum of the velocity of A and the relative velocity of B with respect to A. So in this section, you will see that a plane motion of a slab can be replaced by a translation defined by the motion of point A and a rotation. So where VA and VBA represent the vector sum. So yung ating velocity of A is the translation of the slab with respect to A, and then yung ating velocity of B with respect to A is the rotation of the slab about A and is measured with respect to the axis centered of A. So again, so this part shows the translation or represents the translation of the slab with respect to A, and this part shows the rotation of the slab about A. So denoting by the position vector of B with respect to A, we have the velocity of B with respect to A is equal to the vector product of the angular velocity and the relative position of B with respect to A, or the position vector of B with respect to A rather, in which the velocity of B with respect to A is equal to the position vector multiplied by the angular velocity, where r is the distance from A to B. So yung r natin is the distance from A to B. Therefore, the velocity of B is equal to the velocity of A plus the vector product of the angular velocity and the distance from A to B. So, same scenario, if we use point B as the reference point, the velocity of point A is expressed as VB plus the velocity of A with respect to B. So if you choose point B as the reference point, this would be the equation. So yung substitute natin at this part, it would be VA is equal to VB plus. So let us proceed to the first example. The double gear shown rolls on the stationary lower rock. The velocity of its center A is 1.2 meter per second directed to the right. Determine the angular velocity of the gear and the velocity of the upper rock R of point B of the gear. So we have the larger gear here that is attached to the lower rock and an inner gear that is attached to the upper rock. So since the gear rolls at the lower rock, we can assume that the distance of A is equal to the full revolution of this larger gear, which is equal to, yung one revolution is equal to 2 pi rad, right? So if A will move to the right, the gear will produce a certain theta or certain angle that is in clockwise motion. So our gear is expected to rotate at this motion. So in your statics for unit vectors, it follows that if it is in clockwise direction, it is in negative, and for clockwise or counterclockwise direction, it is in positive, as I have discussed earlier. So we will follow a clockwise direction, negative, and counterclockwise motion as positive. So let us take the ratio and proportion of the movement of A with respect to its rotation. So let's say position of A, yung kanyang full rotation is equal to its circumference. So let's say 2 pi r is equal to, since it is in clockwise direction, so negative theta, and then full revolution is equal to 2 pi. So cancelling this out, therefore the position of A is equal to negative r1 theta. So if we differentiate this formula to obtain the velocity, this is equal to, velocity of A is equal to negative r1 of the angular velocity. And then we are now ready to substitute the values, because we have the velocity of A which is equal to 1.2 meter per second. So 1.2 meter per second is equal to, yung R1 natin is 150. So negative 150 millimeters. So negative 150 millimeters is equal to 0.15 meters. So 0.15 meters multiplied by the angular velocity. Therefore, the angular velocity is equal to negative 8 rad per second. And then, as we have discussed, that the velocity or the angular velocity is equal to magnitude of the angular velocity multiplied by constant k. Therefore, this is equal to negative 8k. So this k is the unit vector pointing out on the paper. So this is only considered as the x and y plane. So yung k natin is, imagine mo na naka-point out to the paper or pointing out directly to you. therefore, this is the angular velocity of the gear. So I will just write it completely. So it is equal to negative 8 rad per second k. So this is the angular velocity of the gear. So next is we will determine the velocity of the upper rock R and a point D of the gear. So our first step is to draw the diagram showing the translation and the rotation of this gear. So for the translation, so let us say this is our gear, and we have point B, point D, this is point A, and point C. So since the velocity of A is equal to 1.2 and is directed to the right, therefore the translation is most probably going to the right also. So the VB, or the velocity of B, is equal to velocity of A, and also the velocity of C is equal to velocity of A, and then the velocity acting at B is also equal to the velocity of A. So as I have discussed earlier, that the translation is constant at all points. So kaya pare-parehas yung velocity at all points. So this is the translation diagram, and then plus yung ating rotation. So again, i-drawing natin siya. So yung rotation niya, so for point B here, point D, and point C. So since yung motion is in clockwise direction yung motion niya, therefore the rotation for C with respect to A, so yung point A pala natin, is papunta dito. So this is velocity of C with respect to A, kasi pa clockwise siya. So D, therefore the velocity of D with respect to A, so pataas naman siya. So assume nyo na lang that is in a vertical straight line. So velocity of D with respect to A, and then the velocity of D with respect to A is pointing to the right. So this is the velocity of D with respect to A. Therefore, it will create the plane motion. So pagsasamahin lang natin itong dalawang diagram na to. So let us draw again the gear. So at this part, papuntang right and then papuntang left, therefore it is equal to 0 kasi yung velocity ng A natin is papunta doon, and then the velocity of C with respect to A. So the velocity of C, so this is equal to 0, and then at this part may vertical and then may horizontal, therefore yung upward and then to the right, therefore it will create a velocity at this portion. So ito yung D natin. So paano ko nakuha to? If I draw imaginary line here for V D with respect to A, and then horizontal for velocity of A, kaya makapag-create tayo ng, and then for point B, so at point B we have a right direction. So ito na magiging velocity ng ating B. So parehas na right. So right direction. And then for velocity A, yan. So the velocity of the upper rock is equal to the velocity of the point B. So kung ano ang velocity na tumatakbo dito sa upper rock is equal to the velocity of the point B. So the velocity of B is equal to the velocity of the upper rock. Therefore, we can say that the velocity of B is equal to velocity of A plus the relative velocity of B with respect to A. And we have our formula a while ago. It is equal to the angular velocity K, and then the relative or the position vector of B with respect to A. So let us assume here x and y plane, and then sa vector niya, x is I, y is j, and then K is pointing towards you or pointing towards the paper, kaya hindi nyo makikita yung relative velocity acting on this diagram alone, because our K is pointing perpendicular to the paper or is pointing towards you. Therefore, let's say that our z-axis is in K. Therefore, yung velocity ng A natin is 1.2 meter per second. So, 1.2 meter per second. So, it is lying at the x-axis. So, I. Tapos, yung velocity or yung angular velocity natin na na-solve natin a while ago is negative 8k. Negative 8 meter per second k. And then, yung position vector natin B with respect to A. So, this is 0.1 yung radius. And then, it lies on the y-axis. Kaya magiging 0.1 meter. J. So, balik tayo sa vector in which ij, the vector product of ij is equal to k. Vector product of j and k is equal to I. Vector product of k and I is equal to j. So take note of these vector products. So take note of these vector products. So i-apply natin siya dito. And which our velocity of b would now be equal to. So this is the vector product. So ito yung pagsasamahin natin. So 1.2 meter per second I. So K and J is equal to negative I. So it is equal to negative 8 multiplied by 0.1 is equal to negative 0.8. So negative 0.8 and then negative I pa siya. So negative I. Therefore, BB is equal to 1.2 meter per second I, negative, so positive plus 0.8 I. So, kung sasamahin natin, so VB is now equal to, so VB 1.2 plus 0.8, so it is equal to 2.0 meter per second. So, ito na yung magiging velocity ng ating B, 2 meters per second. So, take note nyo lang tong vector products na to. So, next, we will determine the velocity of point D of the gear. So, VD is equal to the velocity of A plus the relative velocity of D with respect to A, or D. This is D with respect to A. So the velocity of A is equal to 1.2 meter per second, and it is directed to the right, so I. And then yung W natin kanina is solved as negative 8. So negative 8k. So we will determine the product or vector product, and then yung position vector ng D with respect to A. So this one. So it is 0.15 and it is, so yung pag ito yung origin natin, so it's going to the left, so it is negative I. Negative I. So 0.15 and then negative I. So let us position here yung negative sign na lang, and then I. So it is equal to 1.2I, and then negative 8 multiplied by negative 0.15 is equal to positive 1.2. So positive 1.2, and then K multiplied by I is equal to J. So 1.2J. So how can we determine the product of these two numbers here? So by taking the square root of 1.2 squared plus 1.2 squared. So this is how we add vectors. It is equal to 1.697 meter per second. And then let us take the position or the angle of D with respect to the horizontal. So kukunin natin ito. So if we have the velocity of D, we will take this one. So we can say that for I kanina, so I is 1.2, and then yung J natin is 1.2. So the angle theta here is equal to, so let's say tangent theta is equal to opposite, which is 1.2 all over 1.2. Therefore theta is equal to 45 degrees. 45 degrees. Therefore, the velocity of D is equal to 1.697 meters per second, 45 degrees with the horizontal. So this would be our final answer for velocity of D.